Hello everyone. In this video, we will cover 25 questions and answers using the same method as in our previous video, part 3, where we covered another set of 25 questions. In part 1 and 2, we slowly went through how to find keywords, either in Tom Henry's index or the NEC index. Then, we went the code book to find the correct answer with more detailed explanation. We used the 2020 version of both books. I explained this process fully in the video titled Pass Your Electrical Journeyman, Master or Inspection License Exam on the First Try, Part 1. Please check the description area for link to this course and other courses. If this is your first time on this course, I recommend starting with the first 25 questions, part 1 and 2. In that videos, we discussed the importance of getting the most from these videos and how to best prepare to guarantee a high score on your upcoming exam if you use this series to study for your licensing exam. There, we also explained why Tom Henry's index is essential for your exam preparation, or why using a Smart tab for your NEC codebook is crucial. The good news is that you can take Tom Henry's index to your exam as it serves as an excellent cheat sheet. For this set of 25 questions, like part 3, we will first read the question and identify the keywords. Then, we will use Tom Henry's index to find related keywords and relevant articles in the NEC 2020. After that, we will use the same method to locate the keywords in the NEC index, navigate to the article and find the correct answer. I've also created another course called ChatGPT for Electrician, and the link is provided in the description. In that course, I teach you how to create a free account and how to start using ChatGPT for questions and answers. We cover almost everything you need to know to use ChatGPT like a pro. Then, we use ChatGPT to find the same answers and related articles to evaluate how reliable ChatGPT is as reference for electrical exams, homeworks, daily job site questions, and other related issues. In this series, we also examine calculation questions and compare them with ChatGPT answers. Without further delay, let's go over the next set of 25 questions to boost your confidence in finding answer using Tom Henry's and NEC index, and finally in the codebook. My goal is to provide the necessary keyword to help you find the answers directly without too much explanation to keep this video short. You can explore the details on your own or get extra help from ChatGPT as a private tutor. See you guys in the question 1. Question 1. As a general rule in a dwelling, branch circuits provided to supply receptacle outlets in an attached garage shall have no other outlets. An exception to this rule is A. Receptacle outlets in adjacent laundry room, B. Readily accessible outdoor receptacle outlets, C. Receptacle outlets in the foyer, D. Rooftop receptacle outlets. If we highlight the keyword, we can say branch circuit for garage or attached garage. And if we highlight what we said, we have these two keywords, which is from either of those we should find related article and go to find the answer. In the Tom Henry's index, we have branch circuit garage, which is 21011C4. And in the NEC, we go to branch circuit, but there is nothing as far as the garage or attached garage. We can start our journey from article 210 and go through, or find a starting point like the bathroom, like some area and start from there, which is at least when we have a bathroom, probably around should be a garage or something like that. But you can either start 210 or go a little further to find something around that. And if I go to the NEC 210.11 branch circuit required, when you navigate through, you have dwelling units, then we come down to the 4 garage branch circuit. After reading here, what we're looking is exception, and this exception tells us this circuit shall be permitted to supply readily accessible outdoor receptacle outlets, which is, if we back to our question, the answer should be B. And if I go to find the same question in ChatGPT, I already have the question here. Let's see what the answer is. Is B readily accessible outdoor receptacle outlet, which is referring us in 2017 codebook 210.11C4, which is definitely should be the same of the 2020 because we found the same article. See you guys in the next question. Question 2. A 30 horsepower 480 volt 3-phase wound rotor AC motor has a full load running current rating of A 27 amps, B 32 amps, C 40 amps, D 50 amps. If we highlight the keyword here, we're looking for 3-phase motor, which is AC motor, and we're looking for full load current or FLC. And if I highlight what we said, we're looking for this as a 3-phase wound rotor and looking for full load current for AC motor. If we go to Tom Henry's index, we have motor 3-phase FLC table 430.250, which is generally you have a tab in your code book if you already put tab on your code book. And we go to NEC index, see what we have. If we go to the motor area, then we should go to the FA area to find the full load current, which is ask us to go full load current motors. Then we should back to the full load current motors, which is when we go there, full load current motors, we have for 3-phase, we have table 430.250. And if we go to the same table, we have table 430.250 full load current, 3-phase alternative current motors. I put the question here to go step by step, one by one, to see what we have here in the question. And if we read through, a 30 horsepower, which is horsepower is here, 30 horsepower, number one, 48 volt. When you go here, you see this area is talks about the voltage, and the question asks 480 volt, we have 460 volt. If you see here 2, I put the arrow, it says the current listed shall be permitted for system voltage ranges of 110 to 120, 220 to 240, 440 to 480, and 550 to 60. That means 440 to 460 exactly is the same. Then we can count this column as a 480, and now we are in this column. 3-phase, which is 3-phase wound rotor. If you see here, number 4 wound rotor, and AC motor, which is alternative current motor, or the abbreviation of AC motors, has a full load. When you go right side, when you come down, you get to 40. C is 40 amp, the answer for this question. Now, if I go to the ChatGPT to find the answer, let's see what the answer is by ChatGPT. As we found, table 430.250, 40 amp, which is exactly what we found. See you guys in the next question. Question 3. The maximum ampacity of individual branch circuit in a flat conductor cable assembly shall be A. 10 amps, B. 15 amps, C. 20 amps, D. 30 amps. The keyword can be flat conductor cable and finding the ampacity for branch circuit. If we highlight what we said, we have individual branch circuit and flat conductor. If we go to Tom Henry's index, let's see what we have here. We have flat conductor cable, definition 324.2, and if we go to NEC, the same way, cables, and when you navigate through to F area, you find flat conductor, type FCC, C, flat conductor cable, type FCC. Then we should go to the F section. When we go back to the F section, we have flat conductor cable, type FCC, article 324. If we go to article 324, we go to branch circuit rating because the question asks individual branch circuit. And general purpose and appliance branch circuit shall have rating not exceeding 20 amps. Individual branch circuit, this is exactly question asked us, shall have rating not exceeding 30 amps, which is, if we back to question, not exceeding 30 amps. And this is the answer to our question. Let's go to ChatGPT, see what we have. Here says the maximum ampacity of individual branch circuit in a flat conductor cable assembly is C20 amp, and referring to this article 402.5, which is not the article we are looking. Now, if we go to the article 402.5, which ChatGPT referring us, it talks about ampacity for fixture wire. This is not the flat conductor cable we are looking. I asked ChatGPT, but article 402.5 talks about ampacity for fixture wire and not flat conductor cable. Let's see if it make a correction. And again is 324.10.b. The article is correct, 324.10b, but the answer is wrong, because in the article, if you remember, we had 20 amp is not exceeding branch circuit shall have rating not exceeding 20 amps, but for individual branch circuit shall have rating not exceeding 30 amps. Let's make another question and find what is the ChatGPT can help us or no. And I make another adjustment for question, and I asked, but question asks about individual branch circuit in a flat conductor cable assembly, and say you're right, but the reference number, everything is wrong. And remember, as you see here, ChatGPT can make a mistake. Check important info. Then we just give a feedback as a wrong answer, and we no longer continue because we know per code, which is the answer is 30 amp. And remember, this is a free version of the ChatGPT. Maybe in the paid version they give you better answer, but at least for this question didn't work. See you guys in the next question. Question 4. In dueling units, GFCI protection is required for all 15 and 20 amp. 125 volt receptacle located within at least A. 4 feet, B. 6 feet, C. 8 feet, D. 10 feet of the outside edge of the bathtub or shower stall. The keyword here is GFCI, which is we start our navigation from GFCI protection. Then consider the outside edge of the bathtub or shower stall, and we're looking for dueling unit. If we highlight what we said, we have these three options in our mind. Then we go to the Tom Henry's index. We have GFCI shower stalls 2108A9. Remember, there is another one which is non-dwelling unit, and if you see in the B section, but we are looking for dwelling unit. Don't confuse these two. Then we go to the NEC index. We have ground fault circuit interrupters. When we go down to the D section, we have dwelling unit 2010-8A2. This is A2, but Tom Henry telling us we are A89. We are in the, definitely we are in the A section, but between 9 and 2 there is a difference. Let's go see what we have. If we go to the article in the NEC, 210.8 ground fault circuit interrupter protection for personnel. If we go A2, which is talks about garage and also accessory building, this is not we're looking for bathtub or shower stalls where receptacles are installed within 6 feet of the outside edge of the bathtub or shower stall, which is, this is exactly what we're looking. Then answer is 6 feet. If we back to question, B is the correct answer. And if we go to ChatGPT, I have the question here. Let's see the answer. Which is 6 feet correct, 2108A9. That's correct. See you guys in the next question. Question 5. What maximum percent of metal wireway cross section may be occupied by splices, taps, and conductor at any point? A 20%, B 30%, C 40%, D 75%. The keyword here should be metal wireway, and we're looking for splices, taps, which is these few items can help us find relevant area in the index. Let's go highlight what we said. We know we're looking for a percentage, because if you see here, and these two items as we said, and if we go to Tom Henry's index, we go to wireways, splices and taps, and if you see 75%, we done. The answer is 75%. And as many times I repeated, some of the question in the Tom Henry, it has its own direct answer rather than we go to the article to NEC. Now the answer we know is 75%. Let's go to see what we have in the NEC. In the NEC, we have wireway, metal, article 376. Then we go to see if we find tab or splices. When we go down, we have splices and tab, 376.56. Remember, we're looking for metal wireware. This is wireways non-metallic. We don't need this one. Then we go to the article 376, 376.55 splices tabs. When you read through, you have, which is we're looking for this part, shall not fill the wireware to more than 75% of its area at that point, which is if you, then 75% is the correct answer and is D. If we go to ChatGPT, tell us go 376.56a. Let's see what this article is about. The answer is wrong, but the article is exactly what we found. Let's make a correction and see if ChatGPT make a correction to its answer. I type, but this article says, the same article here, the conductor including splices and tabs shall not fill the wireway to more than 75% of its area at that point. Let's see what the answer is, but for this answer we can feedback bad response, not factually correct. Let's see what the answer is. and now made a correction and says 75%. See you guys in the next question. Question 6. In an underground rigid polyvinyl chloride conduit PVC system that consists of 50 feet lengths between pulling points, what is the maximum number of bends this run may have? A. 4 90°, B. 6 90°, C. 4 120°, D. 2 90°. If we highlight what we have maximum number of bend, and we're looking for rigid PVC. And if we highlight what we said, we're looking for these options as the keywords. When we go to Tom Henry's index, PVC conduit, number of bends, 352.26. We go to NEC index, the same. We have rigid PVC bend. First we're looking for 352.24. If couldn't find, then we go here, then we go there. But let's go based on the Tom Henry's index. Let's go to 352.26, see what we have. 352.26 bend, number in one run. There shall be not be more than the equivalent of 4 quarter bends, 360° total between pull point, for example conduit bodies and boxes. Then the answer should be 4 90°, which is total 360. Let's go to ChatGPT, see the answer. Which is the same article, 4 90°. Then answer is correct. See you guys in the next question. Question 7. Grounding electrodes made of pipe or conduit shall not be smaller than A. ½ inch, B. 3/4 inch, C. 1 inch, D. 1½ inch. The keyword here should be grounding electrodes, and the other related information is pipe or conduit, and we're looking for size. Then if we highlight what we said, we have these options, and we go to Tom Henry's index. We have rod and pipe electrodes, 250.52A5. This is the start point of we looking. And if we go to NEC, when we go to grounding electrode, they ask you see electrodes grounding. Then you should go from the G area to E area to find electrodes grounding. We go there, electrodes grounding. It says see also grounding electrode conductor. We don't have anything here to help us. Let's go to either of these two to see what we can find. Now we go to grounding, and when we navigate through, we have electrode system, which is 250-3, which start article 250.50. Now let's go with what we found in the Tom Henry, and 250.50, which is referring us grounding electrode system and grounding electrode conductor. If you go with the NEC, you should navigate through to find the related information. If you go with the Tom Henry, it's told us come to the 250.52A5, which is when we come to 5, it says rod and pipe electrodes. It talks about rod and pipe electrodes shall not be less than 8 feet in length and shall consist of the following material, which is the question asks us about the material and size. If you remember, the question told us made of pipe or conduit, then this is the material and this is the size. Let's continue. A, grounding electrodes of pipe or conduit, this is exactly part of the question, shall not be smaller than trade size 3/4 and whereof steel shall have the outer. This part is not from a question. The only part of the question is the first part. If we go back to question, 3/4, correct answer. Now let's go to the ChatGPT. I already put the question here. Let's see what the answer is, which is referring us 2050 52A 5B, and they tell us which is 3/4, exactly what we found. Actually, the article referring us we found in the A section. B section talks about, let me go to the B section. The B section type about rod type grounding electrode of stainless steel and copper or zinc, which is, if this kind of the material as a grounding electrode we supposed to use, then the size should be here. Then pipe and conduit is 3/4, stainless steel, copper, zinc coated shall be 5/8 inch. Then what the ChatGPT tell us, the correct answer but the wrong article. See you guys in the next question. Question 8. Liquid tight flexible metal conduit LFMC shall not be used A. in lengths in excess of 6 feet, B. in concealed work, C. in hazardous locations, D. were subject to physical damage. If we highlight the keyword LFMC, uses not permitted, and if we highlight the keyword, we have LFMC shall not be used or not permitted. Then we go to Tom Henry's index, we have liquid tight conduit uses permitted 350.10. We go to NEC index, we have liquid tight flexible metal conduit LFMC, which when we go from A to U section we see is uses not permitted 350.12. Just pay attention, we have another article which is liquid tight flexible non-metallic conduit. Then when we go to the NEC 350 LFMC uses not permitted, it says LFMC shall not be used where subject to physical damage. And if we go to answer, the answer is where subject to physical damage. D is the correct answer. Now we go to the ChatGPT to see the answer, and we have D, subject to physical damage, which is correct answer, but the article is wrong. The article is based on NEC 2017. I already asked ChatGPT, how about NEC 2020? Let's see what the answer is. Give us the same answer, but still the article is wrong. We know the article based on what we found was, if you remember, the article was 350.12, and here they give us 350.12.7, and which is, we don't have any 350.12.7. That's the reason we first check in the NEC, then we go to ChatGPT. See you guys in the next question. Question 9. Determine the allowable ampacity of size 3 gauge THHN copper conductor where given the following related information. 2 current carrying conductors are in the raceway. The ambient temperature is 35 degrees Celsius. The terminations are rated at 60 degrees Celsius. A. 105.6 amps, B. 85 amps, C. 81.6 amps, D. 110 amps. The keyword generally when you looking at question like that, talks about the ambient temperature, current carrying conductor, it says here ampacity. The only thing we need to pay attention, we're looking for copper, and these are the extra information we have. When we go to the NEC code book, we can see what table is, but let's highlight what we have here. We have ampacity, and these are related information. If I go to Tom Henry's index, we have ampacity for aluminum, which is table 310.16, which is, this is exactly for copper too. And ampacity temperature rating. We need temperature rating because of the termination, but when we go to question, we find out what is related to the question. Then we have here connections, and we have temperature limitation 110.14c. Now if I go to the table 310.16, we have this table, which is the table header tell us ampacity of insulated conductor with not more than 3 current carrying conductor. This is whatever you see here, ampacity for 3 current carrying conductor. But remember one thing, this table has note section in the bottom, which is very important. This table is just works if notes 1 section 310.15b shall be referenced for ampacity correction factors where the ambient temperature is other than 30 degrees Celsius 86 Fahrenheit. If you have anything in this temperature, this table works for that. But our question, if you remember, I put the question here. It says the ambient temperature is 35 degrees Celsius. Now is 35 degrees Celsius. Where should I go? You should go to this table, and this table I put across, which I put not 30 degrees Celsius 86 Fahrenheit. Then go to this table. This table give us ambient temperature correction factor based on the 30 degrees Celsius 86 Fahrenheit, and I describe everything here. But let's go to the note 2 section 310.15c1 shall be referenced for more than 3 current carrying conductor. That means if we have more than 3 conductor, then you should go to this table 310.15c1, which I put here 310.15c1, and I said more than 3 conductor. If the answer is yes, then we should go here, and number of the conductor 4 to 6, 7 to 9, and adjustment factor. Because we have 2 conductor, then this table doesn't work for us. The only table we need this table. Let's go read the question step by step and find out what we have. In the question says 3 gauge THHN copper. 3 gauge, number 1. THHN, if I just highlight it here to make it everything clear, THHN and THHN, which is, we call this THHN copper, we call this to number 2, and if you see here, THHN copper number 2. This is not the, actually this should become to here. Okay, THHN, copper, and remember this area is aluminum or copper clad aluminum. We don't have any usage for here in this question. Base ampacity from NEC 2020 table 310.16, the base ampacity for 3 gauge THHN copper conductor at 9060 is 115. Then if we come down from here, go to the right section, we have 115 amp, which is, this is the base ampacity for this wire based on 2. Now section 2, there was a 2 carrying conductor, Step 2, adjustment factor. Since there are only 2 current carrying conductor in this raceway, no adjustment factor is needed. Then we don't have anything for this table. Then we go to the third section, step 3, correction factor. The correction factor for 35 degrees Celsius ambient temperature for 90 degrees Celsius rated conductor, which is 90 degrees here, 35 degree was here for ambient temperature, from NEC 2020 table 31015B1 is 0.96. Now we have a calculation. 115 from base amps here, we put it here, multiplied to 0.96 is 11004 amps. This is after adjustment factor based on this ambient temperature. Now we have a rule here which is now related to termination. Article 110.14c. If we go to Article 110.14c, we see here Article 110.14 electrical connections. If you read here, it says temperature limitations. The temperature rating associated with the ampacity of a conductor shall be selected and coordinated so as not to exceed the lowest temperature rating of any connected termination conductor or device. What is tell us here, whenever you find after adjustment and everything here, you should back to this table, which is now I make another table. This was after adjustment we had 110.4 amps, which is then the rest is this one, considering termination temperature rating. Since the termination are rated as 60 Celsius, we need to use the ampacity from the 60 Celsius column, which is this column, for a 3 gauge copper conductor, which is, if you come down, go 3 gauge here, is 85 amp. Therefore, the following ampacity, considering all factors, remains B 85 amps, which is, the answer is B. Now, I just highlighted here, final answer is 85. After considering termination rating is here. And let's go to ChatGPT, see the answer. I put the question here. If you see the answer is correct, B 85 amps. But the only issue we have, it says for 3 gauge copper conductor, the base ampacity at 90 degree is 100 amps from the NEC table 31016. But when we went to the table, THHN in the 90 degrees Celsius was 115. I guess ChatGPT computes with the 75 degrees Celsius and give us the 100 amp. Let's make a correction and see what the answer should be. I put the new information here and I asked table 31016, the base ampacity for 3 gauge wire THHN at the 90 degrees Celsius is 115 amp. And I guess you wrongly put column 75, which is 100 amp. Let's see what the answer should be after this correction. Said you are absolutely right, and 115, 0.96, 110.04, and the answer is B, correct. Which the good thing is you know the answer from the NEC code and you try to make sure what you find is correct or no, and based on what the ChatGPT give us, we can go to the column, to the area referring us to find out is it correct or no. Is this conversation helpful so far? Yes, we thumbs up, and see you guys in the next question. Question 10. As per a general NEC rule, communications wire and cables shall have a vertical clearance of not less than A 3 feet, B 4 feet, C 6 feet, D 8 feet from all points above roofs which they pass. The keyword here should be communication wire and cables. The other option we have, pay attention to the above roof and clearance not less than. Just consider this one, but probably we start from the communication wire section. Let's highlight what we have. As I said, communication wires and cable. Consider vertical clearance above roof. If we go to Tom Henry's index, we have communication systems above roof, article 800.44b. If we go to NEC index, we have communication system. We start from A, go to overhead, wire and cables, 844. Now let's go to 844 and go to, when you navigate through based on what the Tom Henry told us, go to B section. The B section says above roof, communications, wires and cables and coaxial cables shall have a vertical clearance of not less than 8 feet from all points of roof above which they pass. Then the answer should be 8 feet. D is the correct answer. Now let's go to ChatGPT, see what is the answer is. I already put the question. Let's see the answer, which is based on what we find, 844A and D 8 feet. Then the correct answer is D. See you guys next question. Question 11. Standard trade size 2-inch rigid schedule 40 polyvinyl chloride conduit PVC shall be supported at least every A 3 feet, B 5 feet, C 6 feet, D 8 feet. If you highlight the keyword, which is PVC conduit and supported, because we're looking for the supporting for this kind of the conduit. Let's put here. Then we go to the Tom Henry's index, PVC conduit support 352.30b. We go to NEC index, we go to conduit section, we're looking for PVC. When you go to the R section, it says rigid polyvinyl chloride, C rigid polyvinyl chloride conduit. Then we should find this section. When we go through, we go rigid polyvinyl chloride conduit, which is article 352, looking for supporting, securing and supporting, which is, we should go one by one to see which one is the correct one. But I believe because the article is 352, definitely should be either of those two. Let's go to what we found in the Tom Henry's, and then we go here, which is the same article, just Tom Henry has B section in the end. Now 352.30 B section, it says supports PVC conduits shall be supported as required in table 352.30, which is 352.30 is this table. But I put the question here to go again one by one, find what it says. A standard thread size 2-inch, conduit size thread size between 1/4 to 2 inch. Then we are here. Schedule 40 PVC, which is polyvinyl chloride conduit PVC, and it says shall be supported at least every. When we come here, maximum spacing between support, if you go all the way to the right side, you're looking for 5 feet. The answer is every 5 feet. At least should be supported every 5 feet. We go to ChatGPT. I put already the question. Let's see what the answer is. If you see table 352.30, every 3 feet, which is wrong. Let's see where is the issue is. I made a correction and said based on table 352.30, conduit size 2-inch, maximum spacing between support are different. I tried to figure out if the ChatGPT give me the correct answer. You are right, 6 feet. Still the answer is wrong. If you see it says 6 feet, correct answer is 5 feet. Then this is wrong. We're not going to waste the time, and we thumbs down, not factually correct. See you guys in the next question. Question 12. For an AC system operating at less than 1000 volts, a main bonding jumper shall connect the ground conductors to A. Each service disconnecting means enclosure, B. Each meter base only, C. the grounding electrode, D. all sub-panels. If we highlight what we have AC system, we have bonding jumper, and we have less than 1000 volts. If we highlight what we said, we have AC system, bonding jumper, and we can add this one also, operating at less than 1000 volts. And if we go to Tom Henry, we have grounded less than 1000 volts, which is, or less than 1000 for grounded, 250.24C. If we go to NEC index, we have AC systems, then grounding connections, 250.24, the start point A, but the Tom Henry's start point was C. Let's go and see what we have. We have here 250.24 grounding of service supplied alternative current system or AC system. When we read through, to navigate through, we have C, grounded conductor brought to service equipment, where an AC system operating at 1000 volts or less is grounded at any point. The grounded conductors shall be routed with the ungrounded conductor to each service disconnect means and shall be connected to each disconnect means, grounded, conductor terminal or bus. A main bonding jumper shall connect the grounding conductors to each service disconnect means enclosure, which is, this part is our answer. If we go to back to our answer, to each service disconnect means enclosures, then the A is correct. Let's go to ChatGPT, see what we have. I already put the question here. A, each service disconnect means, which is, if you read through, this is exactly what we're looking. You can ask what the NEC reference is, which is definitely they give you, but that is enough for us as far as to make sure the answer is correct. And see you guys in the next question. Question 13. In industrial establishments where size 1/8 through 4/8 single conductor cable are installed in ladder type cable tray, the maximum allowable run spacing for the cable tray shall be A, 6 inches, B, 9 inches, C, 12 inches, D, 15 inches. If we highlight what the keyword is, we have cable tray and we have installation. We're looking for a spacing between each run. Now let's highlight what we have. We have installed cable tray allowable run. And if we go to Tom Henry's index, we have run spacing ladder cable tray, article 392.10 B1A. If we go to NEC index, we have cable tray. We go from A to I, installation 392-2, which is Tom Henry give us more specific location than the NEC. Then we go to the article, it says part 2, installation. If we read through, we have single conductor cable, and here says single conductor cable shall be permitted to be installed in accordance with B1A through B1C, which is, if we read through for 1/8 or larger, which the question was, they said run spacing for the ladder cable tray shall be 9 inch. This is what the answer we're looking. If we back to question, 9 inch. B is the correct answer. And if I put the picture here, we're looking for this space between these two runs, which is this is should be 9 inches for 1/0 to 4/0 gauge. And let's go to ChatGPT. Let's see what the answer is. Nine inch, 392.10A1, which is, if I back to the Tom Henry's, 392.10B1A, and here we have A1A. Let's see which one is correct. If we back to the NEC code, we see there is no 392.10A1. There is B1, not A1. And I believe the ChatGPT made a mistake. I asked the ChatGPT, which NEC code book is your reference, 2020 or 2017? Let's see what the answer is. They said the reference is 2020. Then we know it's wrong, because in the 2020 there is no article for A1. Then is B1 is correct, and we don't continue. See you guys in the next question. Question 14. The NEC mandates the maximum length permitted for a flexible cord supplying a 208 volt single phase room air conditioner to be A, 4 feet, B, 6 feet, C, 8 feet, D, 10 feet. If we highlight the keywords, we're looking for maximum, we're looking for flexible cord, and air conditions. And generally the 208 volt, which is when we go to the NEC book, we're looking for 208 volt. If there is some possibility for another voltage too, we take a look to that too. But if I highlight what we have maximum flexible cord, which is flexible cord, and room air condition is something we start our navigation and main keywords. The rest is hooked to these keywords. If I go to Tom Henry's index, we have air conditioner cord length 440.64. If I go to NEC index, we have cords. Then we go down to air conditioner, the same article. Let's go to the article 440.64 supply cord, where a flexible cord is used to supply a room air conditioner. The length of such cord shall not exceed 10 feet for nominal 120 volt for a nominal 120 volt rating, or 6 feet for a nominal 208 or 240 volt rating, which is what we're looking for this voltage, which is 6 feet. If we back to question, we have 6 feet. B is the correct answer. Then let's go to ChatGPT. The ChatGPT says the same article, but it says 10 feet, which is, if I back again to article, the ChatGPT mistake is consider 120 volt, but they didn't consider 208 or 240 volt. Let's make one adjustment to see if they find the answer. I just made a correction and the question asked about 208 volt, and I think your answer is wrong. Let's see if it finds the answer. Okay, now it's correct. It says you're right, for a 208 volt single phase air conditioning, this article, and 6 feet. Now the answer is correct. Then we thumbs down here. See you guys in the next question. Question 15. In general, which of the following receptacle outlet in a commercial kitchen are required by the NEC to be GFCI protected? A, all 125 volt 15 or 20 amps receptacle. B, all 125 volt 15 or 20 amp receptacle in wet location only. see all receptacles. The all 125 volt countertop receptacles only. If we highlight the main keyword, we're looking for GFCI section and we're looking for commercial kitchen. Let's highlight what we said. We have these two keywords. Now let's go to the Tom Henry's index. In Tom Henry's index, the closest area we find is a GFCI commercial bathroom, which is, we're looking for kitchen, but wherever is bathroom probably should be garage, should be other like the kitchen. We try to just start from here to looking what we can find, and the start point is 210.A, and let's see what's happening. If we go to NEC index, we have ground fault circuit interrupters, which is for commercial says go 511.12. Let's first go here to see what we have. If we go to 511.12, it says ground fault circuit interrupter protection for personnel. For personnel shall be provided as required in 210.8b, which is referring back to what the Tom Henry's told us, 210.8. And let's go to 210.8, see what we have. Ground fault circuit interrupter protection for personnel. When you navigate through, you come to B section, says other than dwelling unit. All 125 volt through 250 volt receptacles supplied by single phase branch circuit rated 150 volts or less to ground 50 amps or less, and all receptacles supplied by three phase branch circuit rated 150 volts or less to ground 100 amp or less installed in a location specified in 210.8 B1 through B12 shall have ground fault circuit interrupter protection for personnel. One of them is bathroom, the other is kitchen or area with a sink and permanent provisions for either food preparation or cooking. Then this is the answer we have. It should be, the answer should be all 125 volt through 250 receptacles supplied by the single phase branch circuit. If we back to question, the A, all 15 and 20 amp receptacle is the correct answer. Let's go to ChatGPT, see what the answer is. As you see, it says in a commercial kitchen, regardless of their location area, required to be GFCI protected. That means all 125 volt 15 or 20 amp receptacle. Then this is the correct answer, and also referring us to 210.A B2. Let's go back again, 210.A B2, which is correct answer. See you guys in the next question. Question 16. When installing pendant mounted luminaries, the pendant conductor longer than A 18 inches, B 24 inches, C 30 inches, D 36 inches shall be twisted together where not cabled in a listed assembly. The start of our searching starts from pendant mounted or twisted, and also pendant conductors, something like that. Let's go to the highlight what we have. Let's go to Tom Henry's. In the Tom Henry's, we have a pendant conductor, twisted or cabled, which is exactly referring to the question keywords. The other part we can go in the Tom Henry, we can go to twisted or cabled. Pendant cord 410.54C. The first one also was 410.54C. Let's go to NEC index. We have pendant conductor lamps 410.54, which is pendant. Let's go to article, see what we have. 410.54 pendant conductor for incandescent filament lamps. When we go to the C section, it says twisted or cabled. pendant conductors longer than 3 feet shall be twisted together where not cabled in a listed assembly. This is exactly what we're looking. Then the answer is 3 feet. When we back to question, is 3 feet is 36 inches. Then when we go to ChatGPT, I have the question here. Let's see what's the answer. Which is wrong. 41054A is pendant conductor that are longer than 18 inch must be twisted together where they are not part of the listed assembly. Let's go to the article to see what we have. 41054A, 41054A, which is, if you see here, there is no number here which the ChatGPT referring us. But I guess it's wrong. In order to make the ChatGPT for future, let's just make a correction and we say there is nothing as far as those number in the A section. We believe C section it should be the correct one. Let's put the information there. I made a recommendation for ChatGPT. I believe you are wrong and there is not any number related to question in this referring article. I believe you should consider 41054C section. Let's see what the answer is. Still is wrong, 24 inch. I made another correction and I said section NEC 41054C doesn't say 24 inches. If it make a correction, and the correct answer 12 inch. Anyway, this is wrong and absolutely wrong. We don't need to continue, but we know the correct answer is based on the what we found is 3 feet or 36 inches, which is again D is correct answer. See you guys in the next question. Question 17. Branch circuit conductors supplying more than one motor shall have an ampacity of at least A 25%, B 80%, C 100%, D 125% of the full load current of the highest rated motor in the group and 100% of the full load current of the other motors in the group. If we highlight the main keywords, we have branch circuit, and specifically we're looking for motors area and also more than one motor. If we highlight what we said, we have branch circuit, more than one motor. Then we go to Tom Henry, we have branch circuit motors 430.22. We go to NEC index, we go to motors area, we go A through B branch circuit 430-2. When we go to the 430-2 or based on the Tom Henry's 430.22, we have motor circuit conductors, which is we have in the 430.22, we have a single motor. We're looking for more than single motor. We're looking the motor in the group. Let's go navigate through 430.24, several motors or a motors and other loads. When you read through, it says conductor supplying several motors, which is exactly what we're looking, shall have an ampacity not less than the sum of each of the following. 120% of the full load current FLC rating of the highest rated motor, which is the question says here, if you remember, should be at least what percent of the FLC of the highest rated motor. Then the correct answer is D, 125%. Now if we go to the ChatGPT, I already put the question here. Let's see what the answer is. 125%. 125% of the full load current of the highest motor in the group plus 100% of the full load current of other motors in the group. See you guys in the next question. Question 18. What is the minimum size equipment grounding conductor required for a 5 horsepower 3-phase 208 volt motor having 20 amp rated overload protection and branch circuit, short circuit and ground fault protection rated 30 amps? A. 10 gauge, B. 14 gauge, C. 12 gauge, D. 8 gauge. If we highlight what we have, we're looking for minimum size equipment grounding conductor for 30 amp branch circuit protection. And if we highlight what we said, we have minimum size equipment grounding conductor, and also we're looking for 30 amp branch circuit protection. Now let's go to Tom Henry's index. We have equipment grounding conductor size, table 250.122. We go to the NEC index, equipment grounding conductor. We should go to find S area, which is size. We go down, we go from A to B, C, and also S area, which is sizing 250.122. And if we go to 250.122, it says size of equipment grounding conductor shall not be smaller than shown in the table 250.122. Now let's go to table minimum size equipment grounding conductor. These are the same. Now we're looking for 30 amp, 20 amp is small, 60 amp is enough for what we're looking. Then if you come down, go to the right side, 10 gauge is number A. 10 gauge is the answer we're looking. Now maybe asking why we don't consider 20 amp. Just remember the motor overload protection, which means to protect the motor from overheating due to overcurrent conditions, but not directly impact the size of the equipment grounding conductor. Equipment grounding conductor must be sized to handle fault currents, not the motor's normal operating current or overload protection. From the other side, the equipment grounding conductor size must be enough to safely carry the fault current that could occur in the event of ground fault. The overcurrent protection device rating here, which is 30 amp, governs the size of the equipment grounding conductor because it represents the maximum fault current that the equipment grounding conductor might need to handle before the overcurrent protection device trips. Now, if we go to ChatGPT to see what the answer is, I already put the question here. Let's see what the answer is. Which is 10 gauge, and it says based on the table 250.122, according to the table for a branch circuit overcurrent protection device rated 30 amp, minimum size of 10 gauge, which is exactly what we found. And see you guys in the next question. Question 19. If a circuit breaker serves as the controller for a motor and the motor is not inside of the breaker, the NEC requires which of the following? A. The motor to be less than 2 horsepower. B. The breaker be able to be locked in the open position. C. The motor to be code letter E. D. The breaker to be rated 25,000 AIC. Now, if we highlight the keywords, we're looking for controller for motors, and also motor is not inside or something inside of breaker, and these are the location we start to navigate through index. Let's go to Tom Henry's index. We says inside from controller 430.102A, inside from motor 430.102B1. This is as far as the inside controller or motor. Now let's go to NEC index, see what we have. If we go to controller, we just navigate through ABC, we just come to the motor, they send us to motor controllers. Let's go to motor controllers, see what we have. Motor controllers, article 430-7, and let's see what else we have. Insight from motor controller 430.102. Probably this is the starting point for our NEC article. Now let's see what else we have. Again, we have locations, motor disconnecting means 430.102, which is the same article we saw before. Now let's go to article 430.102. When we start the navigate through, we comes to the motor section. A disconnect means shall be provided for a motor in accordance with 430.102 B1 or B2. Now we are B1. Let's go through. When you read through, you come to here, it says exception to 1 and 2. 1 and 2 has its own rule, but there is exception. Let's see what it says. The disconnecting means for the motor shall not be required under either condition 1 or 2 which follow, provided that the controller disconnecting means required in 430.102A is lockable in accordance with 110.25. Then the answer is the breaker be able to be locked in open position. B is the correct answer. Now, if we summarize before we go to ChatGPT what we have, step by step we have identified the relevant NEC section. The relevant section for this situation is this article. This section discusses the requirement when the disconnecting means circuit breaker is not within sight of the motor and its associated equipment. 2. Determine the NEC requirement. This article states that when the disconnecting means is not within sight of the motor, it must be capable of being locked in the open position to ensure that the motor cannot be accidentally energized while maintenance or servicing is being performed. Conclusion: when a circuit breaker serves as a controller for a motor and the motor is not in sight of the breaker, the NEC requires that the breaker must be able to be locked in the open position. This is exactly what we call in the electrical industry lockout, tagout, and this is somehow related to that. Let's go to the ChatGPT. I put the question here to see what the answer is. It says B, the correct answer is B, which is this requirement ensures that the motor can be safely de-energized and locked out for maintenance or service. Then see you guys in the next question. Question 20. For non-shielded conductors of over 1000 volts, the conductors shall not be bent to a radius of less than A6, B8, C10, D12 times the overall conductor diameter. The keywords here should be non-shield conductors, and we're looking for bent radius. And let's highlight what we said. We're looking for, these are what we're looking, and let's go to the Tom Henry's index. Bending radius, non-shield cables, article 300.34. Then we go to the NEC conductors. We're looking for bending radius, 334. If we go to 300.34, it says conductor bending radius, the conductor shall not be bent to the radius less than 8 times the overall diameter for non-shield conductor. This is exactly what we're looking. We're looking for non-shield conductors, but is 12 times overall diameter for shielded or lead covered conductors. Then if we go to the back to our question, is 8, which is B, is the correct answer. And if we go to ChatGPT, I already put here, let's see what the answer is. It says 12 times, which is wrong. And also this doesn't give us what article is, but we know is wrong and we don't need to continue because we can make a correction. And just like the previous question we did, we first ask what is the article about, then we say okay, we think this article is the correct, but meanwhile I put the thumbs down, which is not factually correct. And see you guys in the next question. Question 21. Where an AC electrical service is supplied with 4 parallel sets of size 500 kc mil aluminum ungrounded conductors, what is the minimum size copper grounding electrode conductor required when connected to the concrete encased reinforcing building steel? Assume the grounding electrode conductor does not extend to other types of electrodes. A 4 gauge, B 3/0, C 250 kc mil, and D 2/0. As before, the keywords is electrical service, other should be copper, which is minimum copper grounding electrode conductor, and pay attention, concrete encased. This is part of the question also, we take a look when we go to the answer. And if I highlight what we said, we have electrical service, copper grounding electrode conductor, concrete encased, and this is part of the question also. Let's go to Tom Henry's index. We have grounding electrode conductor size 250.66. Then we go to NEC index. We go to AC system and we just navigate through to find grounding electrode conductor, the same article. And when we go to the NEC book, we have 250.66 size of alternating current grounding electrode conductor. When you read through, you come to the B section, which is talks about connection to concrete encased electrode. That was exactly part of the question, if you remember, connected encased reinforcing building steel. And this was part of the question we already saw. Then let's read through. If the grounding electrode conductor or bonding jumper connected to a single or multiple concrete encased electrodes as described in 250.52A3 does not extend on the other type of electrode that require a larger size, this part of those parentheses assume area of conductor, the grounding electrode conductor shall not be required to be larger than 4 gauge copper wire. Then when we back to the answer is A, 4 gauge copper wire. Now let's go to the ChatGPT. I already put the question here. Let's see what the answer is. Is tell us go to the 250.66. As you see here, it goes to calculate the total cross-sectional area for 4 ungrounded 500 kc mil for aluminum. The ChatGPT answer is wrong and I don't want to go back and forth to make a correction, but let's make one correction to see if the ChatGPT find is mistake. I just put the information for ChatGPT to see if it find the correct answer. Before we start calculation, if we go to article 225.66b, I believe we can get our answer. Let's see what his response should be. Now, based on the just this correction, they gave us the correct answer. See you guys in the next question. Question 22. Where an arc transformer arc welder has a 50 amp rated primary current and a 60% duty cycle, the minimum size 60 degree C-rated copper conductor the NEC requires to supply this welder is A 6 gauge, B 8 gauge, C 10 gauge, D4 gauge. The keyword here is arc welder and a lot of things related to the arc welder. Let's highlight what we said. This is the keyword, and let's go to the Tomher index, arc welders 630.11. Let's go to NEC index, welders electric arc 630 and article 632, which is we start from the beginning to see where we go. And if we go to the NEC 632 arc welders 630.11 ampacity of supply conductor, individual welders, if you read through, it says the ampacity of the supply conductor shall not be less than the current value determined by multiplying the rated primary current in the amps given on the weld rating plate by the factor showing in the table 630.11a based on the duty cycle of the welders, which is, if we come down, this is what the table referring us. I put the question here to see what we should do step by step. First, we determine the welder conductor ampacity adjustment factor, which is based on the NEC table 630.11.a, which is we see here. For this welder, we have, if you see here, it says 60% duty factor. If we find the duty factor here 60%, then we have the adjustment factor, which is here. If you see, adjustment factor is 0.78. Now, what we should do next is the correct calculation should be adjustment primary current is 50 amp, which is rated primary current here. If you see here, arc welder has a 50 amp rated primary current. 50 amp multiplied, we find the duty cycle factor is 39 amp. Then this is the adjusted primary current, 39 amp. Then from here we should go to the 310.16, which is here, to find the ampacity. But remember, I put the information here to see what we have and what we're looking. Here we should, if you see here, it says the minimum size 60 degree. We are in the 60 degree column and we're looking for copper. This area is copper. Everything here is copper over here. Now what we found is a 39 amp. If we're looking in the 60 degree Celsius column, we're looking for wire which is carry at least 39 amp. If we go to number 10, this just carry 30 amp. This is not enough current for what we're looking. Then if we go to the next one, which is number 8, 8 is a 40 amp, then more than what we need. Then this is the correct answer we're looking for, which is, if we back to question, it says C-rated copper conductor, the NEC required to supply this welder is, we should have at least number 8 gauge, which is, the answer is B. If we summarize what we said, we have here a step by step. We have, first we went to the in the table 630.11a for a 60% duty cycle. The adjustment factor is 0.78 as we saw. Then calculate the adjusted primary current. We find that 50 amp multiplied by this duty factor is 39 amp. Then we go to the table 310.16 to find appropriate conductor size for 39 amp at the 60 degree Celsius column. Look up the ampacity for different gauge size in the 60 column to find the minimum size that can handle the adjustment primary current. Here is the information from the 60 degree Celsius column, the wire size, the ampacity. And if you see here, we had a 39. 10 is 30, 8 is 40. Then determine the minimum conductor size. We need a conductor that can handle at least 39 amps. According to NEC table 310.16, an 8 gauge copper conductor is rated for 40 amps at 60 degree, which is sufficient for 39 amps. Conclusion: the minimum size 60 degrees Celsius rated copper conductor that needs the requirement of 39 amps is 8 gauge, and the answer was B, correct. Let's see what the ChatGPT give us. I already put the question here. Let's see what the answer is. We can see the 0.82 is wrong, which is the duty cycle ChatGPT find is wrong. Let's see what is the 0.82. If you see here, there is no 0.82, which is ChatGPT made a mistake, and we know that's a mistake. Really, we know the answer, and we know the answer is wrong. I don't want to go back and forth to fix the duty cycle. I tell the ChatGPT go to this column. This is the primary voltage, which is 50 amp is the rated and that's the reason we don't continue, and we know the answer is wrong. And see you not factually correct. See you guys in the next question. Question 23. When installing wiring for sensitive electronic equipment, the maximum voltage to ground is required to be A, 277 volts, B, 120 volts, C, 60 volts, D, 30 volts. If we highlight what we have as a keyword, we have sensitive electronic equipment, and we're looking for maximum voltage to ground. And let's see, highlight what we said. This is what we have, and go to the Tom Henry's index. We have sensitive electronic equipment 647.1. Let's go to NEC index. We have sensitive electronic equipment article 647. When we go to the article 647, in the scope area it says this article covers the installation and wiring of separately derived system operating at 120 volt line to line and 60 volt to ground for sensitive electronic equipment, which what we're looking for line to line. And if you remember, the question was the maximum voltage to ground is required, then the answer should be 60 volt, which is, if we back to our question, the answer is C, 60 volt. Now let's go to ChatGPT to see what we have. I already put the question here. Let's see what the answer is, which is wrong. Is when installing wiring in sensitive electronic, it says D30 volt, which is wrong. Let's see if we're referring to the article, if we find the correct answer. I asked ChatGPT, what article are you referring? Let's see what the answer is. Oh, actually I asked what's the article is, and say I apologize for the confusion earlier. This is 647.4D. The answer is correct, but let's see what's article referring us. Based on ChatGPT, referring to 647.4D, which is here talks about voltage drop, which is completely wrong article, but I believe this is a confusion by ChatGPT. What is referring, probably referring the same article we find as a 647.1, but the probably confusion is in the article. But anyway, this is the ChatGPT. As I said before, here says ChatGPT can make a mistakes. Check important info. Maybe, as I said again, the paid version doing better job, but at least here is a little off from the topic. Then we thumbs down and not factually correct. We can make a correction, but anyway, that's like rest of the what we did. We get the correct answer, but our main focus is find the correct article with the correct answer in the NEC. Not really trust too much to ChatGPT. We just check and balance with the ChatGPT what we found. See you guys in the next question. Question 24. In a healthcare facility, a patient bed location in a critical care area category 1 is required to have which of the following? A. 4 single receptacles or 2 duplex receptacles. B. 14 single receptacles or 7 duplex receptacles. C. 6 duplex receptacles or 12 single receptacles. D. 8 single receptacles or 4 duplex receptacles. You see here we're looking for healthcare facility as a keyword, and we're looking for critical care area, which is category 1. What we try to find in this area is everything we're looking is related to receptacles. And let's go highlight what we have. We are looking for healthcare facility, patient bed, and critical care area. And as I said, the receptacle is what we're looking. Let's go to Tom Henry's index. Critical care area receptacles 517.19b. If we go to NEC index, we are healthcare facility. When we navigate through A to C, critical care area 517.19f and G. Let's see which one. We start from 517.19 and we go through to find what we have. Then I go to the 517.19 category 1 critical care spaces. When we read through, we're looking for receptacle, which is patient bed, one of the keyword, and location of the receptacle, another keyword. Then we are in the correct area. Let's read through what we need. Minimum number and supply. Each patient bed location shall be provided with a minimum of 14 receptacle. Okay, then this is part of the answer. We're looking for 14 receptacle, at least one of which shall be connected to either of the following. Then when we go a little down in the 2 sections, says these 14 receptacle, which is talks about, shall be permitted to be a single, duplex, or quadruplex type, or any combination. Therefore, that means I can have a 14 single, I can have a 7 duplex, or I can have a, for example, a 3 quadruplex and 2 extra, which is 3 times 4 is 12 plus 2 14. And when we go to answer, the only answer give us what we're looking, 14 single receptacle or 7 duplex, which is 7 duplex multiplied by 2 is a 14. We need to have minimum 14, then B is correct. But C, D, and A is wrong, because if you see 4 single receptacle, which is doesn't make sense because we need 14 minimum. Now let's go to ChatGPT, see what the answer is. Which is 14 single receptacle or 7 duplex, which is correct answer. See you guys in the next question. Last question 25. Flexible cords and cables shall not be used A. as elevator cables, B. when run through holes in walls, C. as data processing cables, D. to prevent transmission of vibration. The keyword is flexible cords. Pay attention, we're looking for not permitted or not be used. And if we highlight what we have flexible cord, not be used. We go start our journey from flexible cord. If we go to the Tom Henry's index, we have cords, uses not permitted, article 400.12, and also we have a cords uses permitted 400.10. Just pay attention, we're looking for not permitted. We go to NEC index, cord, it says see also hazardous classifier location. Then we go to flexible, which is says article 400 4222, which is not really helpful as far as the NEC index, but anyway, we should start from 400. If we couldn't find, we go to next one and the next one. Let's go with what we have in the Tom Henry's index. If we go to 400.10 is use permitted, then we navigate through uses not permitted. if you read through, were run through holes in walls, and the answer here should be B. B is the correct answer. Let's go to ChatGPT, see what we can get from the ChatGPT. 412, which is correct article. Flexible cord and cable shall not be used when run through holes in a wall structure. This is exactly correct answer. We finished 25 questions, deep review by ChatGPT, by NEC index, by article, and I hope you enjoyed. And if you enjoyed, please give the feedback in your message area or give the feedback with the thumbs up, and this encouraged me to create more similar courses to make sure whoever wants to take an exam for any licensing they are looking, in the first try they pass your license, can start your journey for working for yourself, or you can get the higher raise as far as what you get. But I hope I can be part of this success in your journey, and have a great day and see you guys in the future.